welcome back. Today I wanted to talk with you about resharpening slitting saw blades. These blades are used especially on a milling machine to cut narrow grooves, cut off stock, slit parts and whatnot. When they get dull, they will cut very long time still in a dull state, but the cut will wander off and you will end up with a very non-straight cut. Also, they tend to break and bind up when they get dull. So you can either send them out to be resharpened, you can throw them away, which is in a lot of cases, especially with the small ones, the better solution. Or you can resharpen them on a surface grinder or on a tool and cutter grinder. A very brave man could also resharpen them on a milling machine. Just the same setup we're doing now on the tool and cutter grinder. So I want to show you a close-up of the saw blade, so you can see what the wear looks like. Okay, this is a very close-up shot of one of my dull slitting saws, and when I get in here with a needle, this is the cutting edge and this is the back clearance of the cutting edge, and in front here this edge should be sharp, but on this saw blade it's obviously not. There's a tiny radius and you might be able to see this radius just by how the light changes from the surface here on the edge. It's not an edge, but it's a quite wide band that is brighter than the clearance surface, and that indicates that there is wear, i.e. a radius. Also, it has some wear on the edges or on the corners here, out here, and all that will be removed by regrinding the blade. We will regrind the blade on this clearance surface here. Just drop it down a little bit so we get a nice crisp cutting edge and get fresh clean corners here. This down here is called the gullet. This is where the chip that the previous tooth cuts goes in, and this gullet has to be large enough to keep the chip in until the cut exits the work again. Otherwise he will jam up the blade and the blade will wander off, and all sorts of funny things will happen with the slitting saw if you use too fine of a blade, i.e. too small of a gullet. Generally, most people use too fine of a slitting saw blade. For most work you can use a surprisingly coarse blade. Okay, this is my overall setup on the tool and cutter grinder to grind a slitting saw. I have the universal dividing head up on the table in line with the travel of the table and also set to 0 degrees in this setting. The saw blade is held on a stub arbor with a few spacer rings and sits in the spindle of the dividing head. I have a tooth rest and that's mounted to the top of the indexing head or dividing head with a finger reaching down into one of the gullets. I will show that later. The spindle with the grinding wheel is tilted back by the clearance angle that I want to grind onto the teeth, in this case 4 degrees. I'm machining mostly relatively hard materials like steel, tool steel, gray and ductile iron, so a little less back rake is advisable. Okay, here is a close-up. This is the index finger, which is just a bent piece of old hacksaw blade, and this rests against the inside of the gullet of the teeth, just like this. And this gives me always the right index to grind the teeth. On a saw blade, should be able to get away with indexing off another teeth than I'm grinding, because the saw blades seem to get ground out of a hardened blank with an indexing disc on a specialized saw blade grinding machine. Cutters like a T-slot cutter or a dovetail cutter get milled in the soft state, then hardened and then ground. And due to that process, they can have a dividing error between the teeth, uneven divisions. For that reason, on those cutters, you should index off the teeth that you're grinding. But in the case of a saw blade, it gets awful close, and there is really not much space to get the index finger in to register off. It's important to set the index finger in a way that the tooth you're grinding is exactly on center height. This is the finger of a height gauge, and this is set to center height of my indexing head. And as you can see, when I bring it in, it's exactly on the same height as the tooth I'm going to grind. And you adjust this by moving the index finger up and down. Better index finger systems have a micrometer adjustment. I have to loosen the screw on this one and just bump it down with a tiny brass hammer until I get it right. Here you can see the grinding wheel, obviously. This is a CBN grinding wheel. The spindle is tilted back by 4 degrees, and that gives us the clearance angle on this tooth we're going to grind. As you can see, the tooth above it is awfully close to the saw blade, and that's always a problem with tool and cutter grinding. Speaking of always a problem, obviously I'm not an expert at all on tool and cutter grinding. I'm a little bit in the same boat as Steve Summers, who got also a tool and cutter grinder and is also learning the ins and outs of grinding. And he is already far ahead of me. Definitely check out Steve. We're going to grind one teeth, then we're going to index, grind, and so on until we're went around the saw blade one full time. Okay, we're ready to grind. I will have the grinding wheel spin this direction, counterclockwise, so it pulls the burr into the cutting edge. Okay, now we're in feeding. Okay, as you can see, I blued up the teeth of the saw blade with felt pen before I started grinding, and you very clearly can see this small square face here that we just ground on, and this is the new clearance angle, and in front here is the new cutting edge, which should be razor sharp now and give some more life to the saw blade. We will see. I took the arbor over to the milling machine and we're taking a test cut in some gray cast iron. Okay, very unspectacular. The saw blade screams a little bit. That's because my milling machine runs a little bit too fast for this diameter of cutter. Running at 100 RPM, I would prefer something in the 50-60 RPM range for a cut at that diameter. But cuts very nicely, cuts very, very free, doesn't bind up. I'm happy. Seems to be a viable way to regrind slitting saw blades. And no, I'm not going to resharpen all my slitting saw blades. Wouldn't make any sense just efficiency-wise. I have about maybe 150 slitting saw blades in various diameters and thicknesses, and yeah. Most of them are in perfect shape. But if, for some reason, one day the one sawing blade I need is dull, I can help myself. Okay, this is a different setup to grind a saw blade. I have two saw blades on this arbor. This is my master saw blade, and this is an old scrapped saw blade that had half of the teeth removed freehand on a bench grinder. I bought this on an auction in a stack of saw blades. I cylindrically ground all the teeth away to start over from a round blank high-speed steel disc, and now I'm regashing the teeth. I'm using a CBN wheel that has roughly the shape of a gullet, straight side here, small radius, and then it goes over in a large radius to cut those gullets. I'm using the index finger down here on my master saw blade to get the same teeth count on my reground wheel as I have on this one. So I do not need a separate index disc. I can use any saw blade that I have around. And what I didn't expect is the crazy vibration when you take a fairly deep cut. I go down about 1 millimeter, and then I creep feed in, climb grinding. I take a climb cut with the grinding wheel into solid stock, and this thin section of high-speed steel here started to vibrate like crazy. So I took my indicator stand here, and I have one of the arms just pressed up against the backside of the saw blade with a little bit of preload. That helps immensely. Also back here, dust collection to get rid of the high-speed steel dust and the CBN resin dust that breaks off the grinding wheel. So I think I will take one more pass, and then the gullet should be deep enough, at least for demonstration what we're going to do. I'm definitely not going to recut my saw blades, but it's a nice option to have. Okay, I regashed the whole wheel. Now I can change the wheel again, change my setup, and cut the primary and secondary relief. And then we should have a saw blade that's fully functional and working again. Well, we'll see. That's the setup to grind the secondary relief with 20 degrees of back rake. There we go. That was about 2 minutes to cut all the secondary reliefs. Now we will bring in the grinding wheel to a back rake of 4 degrees. And this primary back relief will also form the final cutting edge. Okay, there we go. Okay, there we go. And that was primary relief. Saw blade feels really very sharp. Should cut perfectly. I'm pretty happy how this came out, even if this is just for educational purposes. One important thing when you regrind or grind a cutter that spins is that the cutting edge is actually the highest part of the profile and not some feature along the back rake. So when we run an indicator along the clearance surface behind the cutting edge, we should get a rise on the needle, which tops out at the cutting edge and then drops back. The cutting edge, it needs always to be the highest point. Otherwise the cutter will not cut, it will only rub and produce heat and just not perform as you expected. Looks like a saw blade to me. The tooth geometry is, of course, especially the geometry of the back rake here is obviously completely off, but it should work. Completely rebuilt saw blade, again gray cast iron, just cutting off a slice. I would say that works. Very, very clean cut. Almost like face milled. I'm very happy. This shows me that I have the ability in my shop now to completely rebuild a cutter from scratch if I need to. Or even make a custom cutter if I need, for example, a specific angle cutter. Like a large dovetail cutter with a hole in it, arbor mounted dovetail cutter. I could machine it out of annealed tool steel, harden it, and then grind it into final shape. So many possibilities there. Or I can regrind a large wheel cutter that with larger thickness to be an angular cutter or something like that. Endless fun and endless possibilities with this machine. And as I said before, the saw blade sharpening could also be done here on a milling machine. If you have a dividing head and a cup wheel that you can mount in your spindle, you rig up some sort of a index finger dust extraction, because the ways of the milling machine usually are not protected against grinding dust, and you're good to go. And then you can resharpen your saw blades in your milling machine. So I hope you enjoyed this, me learning or trying to figure out how to resharpen saw blades. Thank you all for watching and see you next time.